Folks, looking at class 66 real quick. We're just looking at some wave interference stuff. So starting with number 2 here, superposition is basically when two waves overlap. Either those two waves can add up to make a bigger wave, cancel out to make a smaller or no wave, or make some sort of new wave shape altogether. This is known as interference, which we saw in lab could be either constructive or destructive. And a really important point is that after the two waves interfere with one another, pass through each other, there's no evidence that they ever interfered. They kind of just go right through each other. It's only while they're overlapping where we really talk about that interference, that superposition. So looking at this here, if we have this first one in number 3 here, we have a +1 wave, if you will, just a crest on the left approaching a -1 wave or a trough on the right. They come together, they're going to have no amplitude when they meet. That's destructive interference. Next one, we have a +2 and a +1. When those come together, they're going to be 3 boxes tall. That'll be constructive interference, and they're going to go right through each other as if nothing ever happened. Then this one here, this is an example of destructive interference where we have a -2 and a +1, and the wave when they meet is going to be -1. Okay, it's going to be like a trough going down one box. Now, a good example of interference are standing waves, which you saw in class. A standing wave is one wave and two waves moving in opposite directions interfere with one another. Forget about this 180 degrees out of phase thing. That was just kind of a, kind of misspoke with that in class. Um, so these are examples of standing waves. We saw all of these things in class. Okay, all with the spring rope. So the node is the part that doesn't move, and the antinode is the part that moves a lot. Now the amplitude, antinode, that's how I remember it. Nodes, no move, that's how I remember that one. And at each one of these little humps, if you will, there's only one antinode. There aren't two here. Okay, so for example, for number 5, there are 3 nodes and 2 antinodes, not 4 antinodes. And there are 7 nodes and 6 antinodes, not 12 antinodes. Okay, that's why I said one antinode here is just like that whole loop, if you will. So here are a couple of quick examples. Antinodes are at B and D, nodes at A, C, and E. Here, this question asks for how many antinodes are there. There are 3 antinodes, and 4 nodes. I just threw that in there. So how can interference be used to explain a standing wave? Basically, the wave generated from one end interferes with the wave reflected from the other end. So there's constructive interference at the antinodes, where you see the big amplitude. That's where the waves, the reflected and the incident waves, are perfectly in phase. And there's destructive interference at the nodes, where they are out of phase by 180 degrees. That's why you have perfect destructive interference at the nodes. So these are just a couple examples of practicing superposition of waves. So for 7a, we'll see this wave here has a +2 and a +1, which make +3. And that's going to be the first crest is +3 tall, and it's 4 boxes wide, just as wide as these were. Then we have -2 and -1, so the next trough is going to be -3. And then +2 and +1, we have +3. So we get a bigger wave because they lined up perfectly in phase. Now these two are 180 degrees out of phase. They're off by, 180 degrees. So how do we add these together? Same way. We have +2 and -1, which gives us +1, which is what we have here when we put them together. -2 and +1, which gives us -1, and +2 and -1, which gives us +1. So we get a smaller wave. All right. So they are perfectly out of phase by 180 degrees. So that is destructive interference. And just an important thing to note is that when waves hit boundaries, they can either be reflected or transmitted. Okay, we saw reflected off of boundaries many places. When I was sending waves on the on the spring rope in class, in the simulation, whenever the waves hit the boundary, they bounced off. Now, waves can also be transmitted. Not something we're talking too much about just yet, but we're going to talk about that a lot when we get to sound waves, and especially a lot when we get into light waves. I think that was all that was there.